For the past 2 decades, NASA's mantra for Mars exploration has been to follow the water. The mission of Curiosity is no exception. Dr. John Grotzinger, mission scientist, explains.
The reason we picked this site is because we see geomorphic evidence, the shape of geology, so to speak, in the form of what's called an alluvial fan, which is a big old pile of debris that was eroded from the mountains in the rim of Gale Crater. And so we know that water was flowing, and it was flowing in the direction in which we landed, which is kind of the low point. It's sort of the valley between the rim of the crater and Mount Sharp. And we're right in the middle there, right in the low point. So if water flows downhill, we kind of think we're in a good place. And so if we go to this rocky outcrop that looks like a layered material, and we might find that we need to drill it. So the reason we put the drill on the rover to begin with was that we might find a rocky material that might have had an origin in water, and we might need to drill into it to get the evidence that we need.
The Curiosity rover carries the first drill to ever visit Mars. But before it can be used, JPL controllers must be satisfied that everything surrounding it is working as planned.
First use of the drill, that's something that we think about a lot, and there's a very important set of precursor events that have to happen before we get the drill out. We're going to try to scoop a sample. So what we need there is a pile of sedimentary material. Maybe it's sand blown by the wind that forms maybe a little mini sand dune or something like that that's out there on the plains. We don't see any of these from where we are. It looks pretty clean of sand, and so that means we're going to have to drive a bit to get one of these. But by getting the scoop before the drill, that gives us confidence that we can then move to the more complicated step of actually drilling.
The use of the drill could be a game changer for the mission of Curiosity.
It is a mission of exploration, and we do set out a plan in advance. And people often hear the expression that planning is everything and plans are useless. And so, if we find something really exciting, we're just going to throw our plans away and replan. And so basically, as we go around and make discoveries, we'll look at our plan and decide if it needs to be changed. But right now, we're kind of hoping that we'll get to our first major rock outcrop to study and be able to really study it in detail, including drilling and using the SAM and Chemin instruments. And then after that, hit the road. Give the keys back to the engineers. They gave them to us to go do some science for a while. We hand them back to the guys that actually drive the rover and get us there, as quickly as possible, maybe stopping along the way to do some science. And I would guess if we followed that plan, it would probably be about a year, 9 months to a year to get there.
By the time Curiosity reaches Mount Sharp, the rover will have many discoveries under its belt. But what do mission scientists hope to find?
As scientists, we talk with each other about what to us would be a defining moment for the mission, where, beyond the thrill of landing safely on the surface of Mars and giving us a rover with 100% capability, what would define the scientific excitement? And I think for us, it is being able, first and foremost, to confirm the things that we saw from orbit, because science is about having a hypothesis, and we have hypotheses from orbit that there are certain features on the ground that are associated with water, evidence of water. We would like to confirm that. And I think if we're able to do that, we'll be very excited about that. That'd be a terrific, thrilling moment. Then, of course, we'd like to go beyond that and see that the way that all the different lines of evidence that come from the different instruments build together to give us a coherent understanding of what the surface of Mars looked like at this particular place over 3 billion years ago. And so it's kind of like thinking of the rover as a time machine. It gets us to a point where we're able to think about what the planet was like billions of years ago in a lot of detail that we've never had before. That, to me, and the chance that we might discover organic carbon, which is really a long shot, reconstructing the early environmental history of Mars, that's what I'm really looking forward to.
This is Rod Pyle for Space.com.
Space.com.